Hello and welcome to a tutorial on the basics of MySQL CRUD in PHP. So what am I talking about when I say CRUD? So CRUD is create, read, update, and delete. So I have noticed that a lot of my viewers are having trouble with queries, and queries are actually quite simple. These are basics that somebody should know before they can proceed with their PHP training. So I figured let me make a video getting back to basics because these things are very important. You shouldn't be having trouble creating queries and reading from the database as you wish. So let's go through what you're going to learn in this video. The first thing is we're going to learn how to connect to a MySQL database in PHP. So we'll learn how to connect there and how to create a table, how to create a database, how to use a database, creating tables in that database, inserting data, reading, updating, deleting from there, and finally how to paginate. So pagination is where you read, let's say you have 1,000 records and you just want to get 10 records, and so you divide the table into pages. So there's page 1, page 2, page 3, and so forth. So let's say you want to read page 10. How do you know how to get the data from page 10? Okay, so maybe we'll add a few fun stuff and so on. But for now, let's begin from the very basic stuff. So forget about PHP for now. We're just going to go directly to the database, the PHP MyAdmin, and see what we can do while we are there. So of course, to be able to follow along with this tutorial, you must have a server installed that has MySQL in it. So for me, I'm using XAMPP. So if you don't have this, download it from the internet. It's completely free. Install it, and then once you are done, open its control panel and make sure you start both Apache and MySQL by clicking any of these two. So in order to follow along here, you must know at least the basics of PHP, just what are variables, what are functions, etc. And you must know some HTML as well, though it's not critical at all. PHP basics required though. Okay. So back to our browser here, I'm going to navigate to localhost/PHP MyAdmin, which is where our databases are going to reside. So all this list you see here are my databases because all these are projects that I've been working on. So to begin with, now it's very important, I must emphasize that whenever I'm typing the queries here, you must type along as well. This is very important. Do not feel lazy to type these things with me because it's in this muscle memory that you're building that you're going to become an expert. So you will never become an expert by just watching somebody do it for you. So you must do it yourself. So you can watch the video, pause it, get back and try some of this stuff, mess around with it and come back to the tutorial. So that's okay. As long as you're typing it yourself, that's important. So we can click here and create a database if we want, but we're trying to teach queries here, so forget about that. We're just going to create this using an actual query. So to do that, we'll go to the SQL tab here. All right. Now keep in mind that whatever query we run here, you can run that query using PHP. So I'm just showing you the basics of queries, and just remember that whatever you learned here, when I teach you how to connect in PHP, you can run those queries just as well as running them here. So here what we would do is we want to create a database. So what will be our database name? In our case, we're going to call it CRUD just for simplicity. So to create a database is very simple. You just say create database. So I will create a new page here for our sample queries here. So we'll say create database like so. This is how you write the query, create database, and then you give the database name. In our case, it's going to be CRUD like this. I don't know what I just typed there. CRUD, and let's put underscore DB. It's just a good idea to put DB there just so you remember what you're doing. Okay, so CRUD DB, that's okay. That's all you need. This is a query enough to create a database. So let's copy this query and put it here. Now I could have typed it here, but I wanted you to see it there because that text there is a bit bigger. So create database CRUD DB. Simple and straightforward, right? So now if I click go like this will create a database. On the left here, you see there is CRUD DB. As simple as that. And it actually shows you that this is the query that was run during that operation. So let's go back to the SQL tab. Now we need to tell it that we want to use this database so that whatever commands we are doing from now on will be centered on this particular database. Okay, so to do that, we're just going to say use CRUD. I don't know why I keep typing D there instead. CRUD DB, like that. So by saying use CRUD DB, you are telling it to use that database. Okay, so if I now click go, that's the database in use now. Okay, so use CRUD. Okay, MySQL returned empty. Okay, no database selected. Why? I have no idea why it's not selecting CRUD DB. Error, no database selected. But I just told it to. Anyway, it doesn't matter. But inside PHP, if you want to use a database, this is what you would do. But let me just click it here so that it says DB is equal to CRUD at the top there, so we know we've selected the correct one. So now let's go to our SQL tab once again, and this time we want to create a table. Now I want to create a table that will have users, so it's going to be called a users table. So let me come down here and let's add to the list. So we're going to say use CRUD. So I'll leave this here just for the sake of history, like that. Okay. So in order to create a table, we're just going to say create table. Now, there are some times that you want to create a table only if it doesn't exist, right? So you can put create table if, like that, if not exists, like so. Now, many people like to use capitals here just to differentiate which ones are the keywords, etc., etc. You can do that, no problem. So it doesn't really matter. These are not case sensitive. So even if I add E like so, it's just going to know what I'm talking about still. So create table if not exists, and then you write the name of the table. So this is going to be users, like so. So once you type that, it knows you're creating a table, but you have to give it the column names, the column types, etc., etc. So here we're going to put a bracket like so, open, close bracket, put your comma, semicolon there, because always these are commands. You have to put semicolon at the end if you are running these. The semicolons are only important if you want to run, let's say I want to run all these at once, because I can run all these at the same time. I create a database, use it, and then create a table all in the same. I can copy all this and paste it in that box and it will run at the same time. But I need these semicolons to tell it where one command ends. So because we want to add columns in here and they will all fit in there, I will do this. Okay, so here I want to tell it what columns, what will be the names of my columns. So the name is ID, for example. Now that's the first column I want to put. Now if I'm going to add spaces in columns, I will put the inverted commas like this, but I don't recommend you put spaces. Use underscores instead if you want to space words. So the ID here, now we want to tell it what type of item this is, what type of column. Now there are several types here. Now in our case it's going to be int, like that. Now there's int, there's also big int, like that, which is bigger than int, of course. There's tiny int, which is a very small int, and then there is variable character like that, which is just normal text. Those other ones are numbers. And then you have decimal like that. You also have blob, which I never ever use. And then you have text, which is if you are going to save a very long document, right? So those are the ones that you should just keep in mind. The rest you can check here if you want to know. Let's go back to our thingy here. What I can do is go to the structure of any other, or I could pretend that I want to create a table here. If I click create table and say go like this, I'll just write something here. It won't create the table yet. It's just going to give me the options to create one. So here, if I select type here, you see, this is the type that we are dealing with. There's all this, there's date, there's, which I never use as well. The important ones are int, variable character, text, and then tiny int, which I often use. There's big int as well. There's decimal. I use that one. And then I use date time. The others, not so much. It depends what kind of work you do. You may be using the others more than the others. But the ones I've pointed out, those are the ones I use. Int, varchar, text, and then tiny int, big int, decimal, and finally date time. So we can choose one of those. Yes. Now I want this ID to be the primary key. So I'll just use int like this. Int is quite big. It's like, I think it's like 10 digit number, which is quite big, if I'm not mistaken. Actually here, if you want to know the lengths of these things, if you hover on the thing, it brings something that shows you the length. So int here is 4-byte integer. Signed range is minus, and then unsigned range is 0 to, so it should be unsigned. So you see there's two types. There's signed. If the int is signed, it means it can hold negative numbers. If it's unsigned, it will hold positive numbers only. So we want it unsigned because we want to just add numbers from, use numbers from 0 to 4 billion. Is it 4 billion? Yeah, I think 4 billion. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, so it's 10 digits long, but big int is 20 digits long. So it's insane, but that's what we have. So ID there, we say ID, that's the name of the column. Int is the type, and then we will tell it that it's unsigned. We just put them like that, and then we want to tell it that this is the primary key. So we say primary key like that, and then we want it to auto increment. So we say auto underscore increment like that. So all these are the instructions for this particular column. So most of the time you may need to do this for the primary key. Okay, so just keep that in mind. And then now we can put a comma, and then we give it the next item. So the next one, we want to add a user's name. So we're going to say name, and then we will tell it what type. So we say varchar. Now normally when you give a type, you're going to put brackets like so, to tell it how long the item is. So if I go back here, you will notice that here it tells me the length and values. So normally we put numbers here, but for int, it knows how long int is, unless you want to specify a smaller number. Now what these lengths mean is that if you add data that is bigger than the lengths you've defined here, it's going to be truncated or it's going to be cut. Let's say you put 2 in here for variable character, and you put a name with 4 digits or 4 characters. It's going to remove the last 2 and just save what it's allowed to save. So if I put 2 here, it means I can save 0 to 99, because 99 is 2-digit number. 100 will be a problem. It's going to save that as 10. No, actually, it's going to save it as 99, I think, since this is an integer. But you get the idea. So this is the length, the number of characters it can hold. So normally here we would put something like this, 10, but it's implied because it's int, so we don't need to put it there, but you can add it there if you want. So name here is, it's going to be the length or the character count, which is like this. So name varchar like that, and then we put a comma. Okay, so here the next thing is to I think I'll have another one called email. It will probably be the same, varchar, maybe 100, like so. Okay. And then finally, we'll add a date like this, and we'll call this one date time. Now, as usual, date time will be implied, the length, so no need to add the length there. I'll put a comma. So now we want to add some index. Now this one already has one because we've added the primary key, but I want to be able to search for things using this, using the name and email, maybe even the date. So I can add some indexes here to these guys, just the way this one has a primary key, right? So how do we include those in the query? So we're just going to say index here. We'll say index, and then we give it the index name. Okay. So what will be the index name? We'll just name it the same name as the column. So we'll say index name, and then in brackets, we tell it which column we're targeting, which is name as well, like that. Now, the thing is, I'm not really sure which one is the index name and the column name, but you can experiment with that. Just change, because the index name doesn't have to be the same as the column name. You can have them different, but you can experiment and just put a 1 here and see if you get an error saying it doesn't know what column this is. Then you know, okay, the 1 should be on this one, which means this is the actual name of the index. The other one is the column name. But for me, always I just put the same name as the column. So this is why I actually don't remember which is which. But then we can add another index, which is, let's say in this case, this is email. Okay, like that. And then finally, another index for the date, like so. Okay, pretty cool. Now, don't forget that we have an opening bracket here, and there's the closing bracket. Okay, that's good. And then after this, you can still tell it what engine to use. Now, this is optional. You don't have to write this, but you can say engine, something like InnoDB, and then you say default char set, the character set, which is a UTF-8 MB4. That's what, those are the things, but this is optional. No need to memorize this. Okay, so at this point, make sure that there's no comma at the end here, otherwise you have errors. And this engine type is outside this bracket, okay, at the end. So keep that in mind. And then also, you can tell it what default value you want in these, because sometimes you may not want to save the data directly. Maybe it can have a default value for name, default email, or default date. Or sometimes you may have a column that says male or female, for example. Gender, you may put 1 or 0 for gender, and you may want the default to be 0, or etc, depending on what you want. So here I'm just going to say gender. I will add that there. And then for gender, I will say tinyInt. I can use tinyInt, or let's use variable character and just put 6 for male or female. And I want to add an index as well for gender, just so I can use gender to search. Don't forget the comma there. Only the last one shouldn't have that comma. And now in gender, I can put a default value if I want. I just say default, and then default like that. Then I can say male like this. Then that will be the default value. Or if it's a number, I can say default 0. Or if I want this to sometimes not have a value, I can put no like that. Okay. And if you don't want this to be empty at any time, you can say not no like this. Then the database will cause an error if you don't put a value for that column. It won't save the information. So that's what not no can do. If you want it to be no, you can just say no like this. But this is for the default value, which in this case we've said should be a no, like this. Okay, so all these are things you can add. Same thing here, you can add a default value. You can just say this can be a no. But in our case, we don't need any of this, so remove. And like I said, for date, you can tell it default. You can say now, something like default now. I think this should work. I'm not sure about that, but this should give you the current date. Whatever the time is, it's going to be saved automatically. But don't hold me on this one. Just figure, you can Google it to figure out what the default is for there, because I don't have it on the top of my head. But so far, what we have done is create a table with all the details that are required. So let me just copy all of this and try to run it in our thingy here. So instead of creating the table from here, I'll just click on the database and go to SQL, just to make sure that this is the selected database here, and paste the data. So you can see that it has recognized some of these guys. And now if I try to say go, let's see if we get any errors here, and you see there are no errors whatsoever. If you do get any errors, it's going to tell you exactly where the error is in the query. Then you can check that text out. So now we have a table here. If we go to users, and now you see when I click there, it's actually running queries as well. So you see this is a query here that says select all from users. This is the default read query right there. So when I click there, I'm running a query as well. So if we go to the structure of the table, you can see exactly how the table was designed. So you see here it allows no object. The default is no. No, is this allowed? Yes, this allows no values. Okay. And these are keys here, the indexes we added, and this is the primary key. That's why it's yellow like this. And you see the auto increment there is added. And this made sure that it's unsigned, right? From 0, just positive numbers. When it's unsigned, it only gets positive numbers. And the int, you see, it's 10. That's the maximum. This is 30, that's 100, this is 6. So everything seems fine from what we have done here. So good, this is how you create a table. So let's come back here to the CRUD and see. So far, connecting this, we'll do this in PHP, but we know how to create a table, a database, sorry, to use the database and to create a table. Now we just want to know how to insert some data, because we have no data in there yet. So let's see how we can actually insert something. So if I come back here and go to browse, keeping sure that we have the correct database selected, it says DB CRUD, that's the database here. And we have the table selected. Now we don't need to have the table selected. We can just have the database selected. That's okay. And we go to the SQL because we're going to specify the table that we want to insert. Now remember that in the table we have all these columns, so we should remember them in order to be able to use them. So if I click on columns here, you see these are the columns. There's a date, email, gender, ID, and name. Now, if you allowed some of these to have no values, then you can omit them in the insert. But if you didn't allow that and you omit them, the data will not be saved. It will tell you that this column cannot have an empty value or something like that. Then you know that you missed one column. Okay, so here we're going to create a query for reading. So maybe let's type it from here this time. Now we're going to say insert. That's the keyword there, to insert something in the database. You say insert and then you say into, like so. Insert into, and then you specify the table. Insert into users. Now you will notice that in the insert we don't specify the database. This is why you must have selected the database before. So by using what I had told you to say use and then you type the database name, you can switch between databases when you're running queries. So I can run a query now and say use this database, and then run some query here, and then go here and say use, and then use a different database altogether. So this is why the use database can be useful if you are shifting between databases. But that's very rare, so unless you have multiple databases. Usually having multiple databases on one project is a result of poor planning. So normally you must have just one database. Anyway, insert into users, and then you say what you want to insert in brackets like so, and then you say values, and then you put your values in brackets. So this is the basic syntax here. Insert into the table, and then you put your columns and you put your values. Now you can remove this entirely and not put your columns there, right? You just put values. But the issue here is that you must be very sure the order of the columns here. So if the order of the columns starts with name, email, and so on, this is the order it's going to follow. You must follow here, otherwise you find one piece of data in the wrong column, etc., etc. This is why it's a better idea to line your columns here and then put your values there, because even if you swap your columns here, for as long as the data is also swapped equally, the data will end up in the correct column, because it just looks at what columns you have, what order you have here, and follows that same thing for the values. So here I will type in my column names without quotes. So it's going to be name, email, and then so name, email, and finally, what else do we put there? Gender and the date. Yes. So the order doesn't really matter as long as the data is the same order as well. So 1, 2, 3, 4. Let's come back here to the table create so that we can refresh our memory. We don't need to worry about the ID because it's a auto increment, and so it will increment itself. So name, email, gender, date. That looks about it. And then here now we are going to put, now you can put these on separate lines, it doesn't really matter as long as you don't put a semicolon, it's good. So here we'll put a name like John. We'll put the text in quotes because we could have spaces there, and then the email could be john@email.com, like so, and then comma. Now we put our gender. This is a guy, so that's male, and then we put our date. Now the date should follow the date format. Now we put date time because we want to put the date itself and the time. Now if you don't want to save the actual time that something happened, you can save some data by just selecting date instead of date time as the column name. So here where we selected date time, you can just say date. Then it will just take in the month, year, and day without the time itself. So here what we can do is we create a format. So our format is year, month, and then day. So in our case, this is we can put any date here. Really, we say 01 dash, you can use the slash or the dash, it's acceptable. 08, and actually this is the opposite. It should be 2021-08-01, and then put a space, and we put our time. We can say I don't know what format to use, like this, and you can put your seconds if you want as well. It's up to you. So this should be valid data. So let me copy this in case we have a problem, we can revert to it, but this is how you insert. So all I'm trying to do here is match the name with the first item here, the second item with the second, and so on and so forth. Put them in quotes, it's good practice, and then just remember that it's insert into the table, columns, values, and values. So let's run this real quick. Run that. Okay, data truncated for column date. So it's telling me that the data was too long. That's because instead of 2021, I wrote a monstrosity here for some reason. So this is why it's saying data truncated for table date. Truncate means to cut. So let's come back here to the why are we going to the structure anyway? Oh, users. There we go. We didn't select a table. So you see the date was not recognized. This is why it wasn't saved properly. But as you can see here, there's a familiar format here. That's the year, month, day, and then the seconds. So we'll try again. Let's try and insert a second. So I had copied that. I will paste this here. And this one, let's change John to Mary. And I will change Mary there as well. and then I'll change this to female. This time let me try and put a plausible date, and let's hit go. There is this. Go. Wrong place, is it? Copy that. Go. Okay. I don't know why it was this time we didn't get any errors. So if I go to browse, you see that this time the date was saved because it was the correct format. Okay, so this is how you insert information into the database. Let's insert one more just to make it easy to read, so we have more data to read. Let's go back here, SQL. Let's add one more. So I'm going to change this to Peter. These are the generic names I have in my head, like so. And male again. Let's say time has moved, maybe it's 30 minutes later, and let's hit go. Yeah, back to browse, and there we go. We have 3 people, but one more just for the heck of it. Yeah, because we're going to need pagination, so at least we should have enough names. So let's see, Joseph, maybe. Yeah, you can't have Mary without Joseph, right? So let's do that, and let's say 45, maybe 10 minutes later, and let's save. I don't know why this is acting up, but there we go. So if we hit browse, we have four records. Yeah, enough for pagination. Okay, so this is awesome. This is how you read or how you insert data from into the database. So I'm going to add this here as well, paste that. I will make this file available so you can go through these just to know in case you don't remember what's what. Okay, so at this point, yeah, let's try we've inserted data. Let's try to read from the table at this point. All right, so actually let's keep the read for now because there's quite an amount of things to talk about with read. Let's go to update and then look at the delete real quick. So if I get back here, if I want to update a record, now this is where the indices or the index we created comes in, because I have to specify which row I'm talking about. Because if I just say change in the column name, change the name to this, there's so many records here, it has to know which one I'm talking about. So I have to use one of these columns as a unique identifier. So for example, if I use gender, this is not going to be very good because there are several items that are named male here, but I could do that because it's possible that I want to change all males in here. I want to add something to one of their columns. So in that case, I would say where gender is equal to male, and then it will find every instance where that is true and then change accordingly. However, if you want to change just one row, you must choose something that is unique. In our case, we have a primary key here that is auto increment. So even though I delete, if for example I delete this row here, it's still going to write number 5 as the next one because it doesn't want to repeat itself. So you can always be sure that the primary key is unique. So you can use that if you want. But sometimes you may not know what the record number is. You may just know the name. So if you're sure the name is unique, you can use that. You can use any of these, even the date. Now, if we go back to the structure, this is where you see that we added some indices here. So let me explain a little bit what these do. So this is an index here. This is why you see these keys here. So the index means the database is going to create a separate table that is going to index the values that are in here, in these columns, right? So as you can imagine, this makes the table a little bit bigger because it has to save extra information about these columns. This way, it's going to add numbers to these things so that let's say you want to retrieve a specific record, it's going to skip other records, instead of going line by line, checking to see if everything matches, it's just going to skip to a very specific set of records to find, right? For example, if you are using the ID column, now this ID is auto increment and it's numeric, so it's easier to understand. So what will happen is when you say where ID is equal to 20, normally what would happen if you don't have a key, it's going to check row number 1 and say, okay, is this row bigger than 20? No. It will go to the second one, the third one, and so on. But with an index, it will already know that 20 starts from here, and then it will just check, maybe to check between 19, 21, and say, okay, it's somewhere in between here, and then it will find it quicker. So one thing to take away from this is that an index speeds up your reading time. Now, reading means when you're updating, when you are deleting, and when you are wait a minute, when you're updating, all that requires retrieving a specific record is reading. So during those times, it speeds things up, but it slows things down when you are I think maybe in the update, I'm not really sure which one it slows down, but one of them slows down while the reading process speeds up. So it's a balance that you have to strike here. You have to make sure that whatever you're going to use to read information has a key, but you don't put keys on everything. You limit how many keys you can put because it increases the table size. At the same time, you have to put a key to speed up your read time. Because think about it, in your website, the majority of operations that happen is read, because every time somebody clicks a button, they are reading from the database. So that's the majority of things they're going to do. When they want to update something, it's once in a while when they are changing settings or changing something like that. That rarely happens. So that's why keys are quite important, even though they make your database bigger. So in here, let's try and change the name Mary to Mary2. So one key identifier is the ID, which is equal to 2. So let's use that, shall we? Now right here, I can just say edit inline to edit what's already here. So it says select all from users. This is generic. If I say this, I'm reading all the records in the database. But if I put a where clause like this, it means I'm telling it to only get a selected number. So I'm just going to say where ID is equal to, and then I'll say 2, something like this. So select all from users where ID is equal to 2. Now we're not selecting here, we want to update, okay? So this would be selecting. So this has to evaluate to true when it reaches a specific row. If it's checking for rows, when this is true, it's going to say, okay, that row is the correct one. So if ID is equal to 2, in this case ID column is equal to 2, then that is the correct one. But we're updating, so I'm going to say update users. So this is how you do it. You say update users, which is the table name, and then you tell it what to set. So you say set, and you specify the column. So I want set name is equal to, so name is the column, it's equal to, I want it to be equal to Mary2, like that. Okay, so this is how you tell it what to set. Now if I omit the where clause here, it's going to update every single record. So this is going to work still without the where clause. However, it will update every record. So if you want to update every record, maybe you've created a new column and you want to add some default data, this is how you would do it, because every record will be updated with a specific value. But in our case, we want a very specific thing, so let's hit go. Now, once we do that, if we go to one row affected, so it tells you that we did edit one row. So browse, and you see now Mary is equal to 2. This is how easy it is to update things. Now you could set it to look for 2 columns, because here we just told it ID is equal to 2. Okay, that's fine, but let's edit this back. So if I go to edit inline, I can say update users, and then I tell it what to set. So I'll say set name is equal to Mary. I want to set it back to Mary. Now, in an event where you want to change several columns, right? Let's say you want to set Mary is equal to Mary, name is equal to Mary, and gender is equal to male. You would put a comma here and say something like gender is equal to, and let's change that to male just for fun. So you say set name is equal to this, and then you put a column, say gender is equal to this. So set is only put once, but then you put everything that you want to set to something else, and then you tell it where, because if you don't tell it where, everything will be changed. So here we say where ID is equal to 2. Now we can also use a second column. Maybe there's several columns with the ID 2, right? But then you would look for another unique feature of that row that you are trying to read. So you can say where ID is equal to 2, and then you say or if you want it to be an or you can use and if you want both conditions to be true. So when you use or like this, let's say for example I say or name is equal to Mary 2, like that. So this will work because it will find if this is true, it will work on that same row, or if this is true, it will work on that same row. Just in case this returns false, it will still check for that. So when it's checking, it will check if this is true. If this one becomes true, then it won't bother with this at all because it's or. But if this is false, it will be forced to check this one as well until it finds one that is true, and then it will do the edit. However, here we'll do and, so meaning that both conditions must be met in order for the change to happen. So we'll change name to Mary, gender to male, where ID and name is equal to ID is equal to 2 and name is equal to Mary 2. So let's try this out. One row affected, very nice. So you can see now that has changed to Mary and that has changed to male. So as you can imagine, if I want to change this back to female, I'm just going to use the ID this time. So edit again inline and say update users and say set gender be equal to female, where ID is equal to 2, and go like so. One row affected, very nice, and there we go. So everything is back to normal. So that's how you update your records. Okay, so from the update, now we can go to delete. Now delete is a lot like update. The only difference is that you're not providing any values because there's nothing you're updating, you're just deleting a row. So all you have to do is specify a unique identifier again to tell it which row you are deleting. Now I kind of like all these rows we have here, so let me create one more that we can delete, right? So let's come back here to the insert, select all, paste, and this one I want to, oh, sorry about that. I want to change my values here. Let me just put 33 there and 33 there just to make it different. And let me save that. Insert, go. Okay, so one row inserted. That's nice. And we have it right there. So the ID for this one is 5. So as you can imagine, I can use 5 as the unique identifier, or I can use the name as the unique identifier, or the email as well. Regardless, for as long as it has an index, it's all good. Now, if the table size is small, you don't really need indexes. For example, if you know that the users on your system may not be more than 20, for example, then the indexes are not required, but the primary key is required still. But if you have 1 million rows in your table, then your index will come in very handy in that time, because you don't want users clicking and waiting so long to get their results. Okay, so let's go to the edit inline here so we can create our own query, and I'm going to say delete. So you say delete from, like so. Okay, so delete from users, Now, if I just run this as it is without a where clause, it's going to delete all records. So you must be careful how you do this. So delete from users will delete everything. However, you can add a where clause to limit that deletion, and we'll say where ID is equal to 5. So as with the previous thing, you can add and if you want, or you can add or and put a different condition. Now you can add many conditions, as many as you want, as long as you put commas, not commas, sorry, you put or and like this. Now sometimes you may have several ors and several ands, and it may become confusing as to what the result will be. So in that case, you may put brackets like this. Okay, so you may say maybe where ID is equal to 5 or ID is equal to 6, and then you say and name is equal to John, something like this. So you see, in this case, what will happen is if you put brackets like this, anything in brackets will be evaluated first. So brackets of like the famous BODMAS. So there's brackets and multiplication, etc. So the brackets will be evaluated first, which means this will evaluate to a specific result, and then that will be used to AND this result. So if ID is equal to 5 or ID is equal to 6, so if any of these are correct, then it will make sure that at least one of these is correct and this is correct in order for it to run. So if you get confused, just put brackets around which ones you want to evaluate first. So you can even put brackets like this, you see, like so here, and then you continue with and then you put another ID is equal to 20, something like this. So here what will happen is this will be evaluated first in here, this, and then the result will be used as the AND to this, and then finally the whole result will be added to that. So you can use this for all queries, whether it's update, it's delete, as long as it's a where clause, you can do something as sophisticated as that. But for now, we don't want all this, we just want to delete ID number 5. So where ID is equal to 5, go. Now, do you really want to execute a delete? Yes. One row affected. Okay, that's good. We just wanted to affect one row. So there we go. We have everything we need. So that's how you delete with SQL here. So let me try. I didn't save the other ones, unfortunately. So I'll say delete from users where ID is equal to 5, just in case you forget how to do this. And the update is update users set name is equal to Mary2 where ID is equal to, oops, what have I done, is equal to 2. Something like this, right? That's how you update, that's how you delete. Now let's look at reading from the database. Now this one can be very easy and can be very complex, because this select statement can be combined with so many things to read data. So for example here, if I try to edit this inline, you see now it says select from users, right? So this will select every single record in here. So if there were 100 records, it will show all the records here. And then the second thing is that you can add a where clause here and tell it exactly which ones to get if you want a very specific row. So I can say where ID is equal to 2, for example, and hit go. You see that only one record is returned. So let's edit that again, and you can say or ID is equal to 5, like that. Open up. So where ID is equal to 2 or ID is equal to 5. Wait a minute. Anyway, it's an or, so I guess it returned 1. I have no idea why that is. So now if you want to return a random amount, a random set, actually before we do that, let's look at how to limit results. So if, for example, I can say where ID is greater than 2, if I hit go like this, it will show me all the records with an ID greater than 2. There we go. Now I get 2 results here, but I can tell it to limit to 1 result or 10 or 20 depending on what I want. I can say where ID is greater than 1 and then tell it to just limit like so, limit 1. Okay, so that limit tells it that I only want 1 result. So go, and you see it will show me an ID greater than 1, limit 1. I can change the limit to something like 3 if I want to, and hit go, and it will show me 3. Now because there are only 3 records here, I can say limit 30 and it won't get an error. It will just get as many as it will find and limit accordingly. Okay, so limit 30. Good. Now the other part of this is, so you can use here greater than, less than, that's up to you. And you can also use, instead of equals, you can say like this. So where ID like 1, limit 30. So let's see here. So like is kind of like an equal sign, right? So like equal sign. Now the only difference is that with like you can use it to search. You can do advanced searches, like for example, I want to search for any name that has O. So I will use like, instead of ID, I will go with name. I'll say where name, because sometimes you may say name is equal to John, but maybe you just know part of the name. This is how you search. So you say name like, and then I can write something like Joe, like this. Okay, but if I try to find this, it won't find anything, because like is just like equal sign. But the advantage with like as opposed to equal sign is you can put wildcards here. So I can tell it that I just want the name to start with JO, and then at the end here just put a % and say I don't care about the characters here, they can be anything for as long as it starts with JO. So if I click go, you see that now it will give me any name that starts with JO. Now if I put H, for example, let me just put H here and try go. You see that I get no result because none of this starts with H. However, I can put another wildcard at the beginning and say, okay, I don't care what's at the beginning, I don't care what's at the end, as long as there's H somewhere in the middle. So if I click go now, you see that it will give me those results. Again, if I put an M there, edit inline, M, it will give me something which has M anywhere in the text, like that. Okay, great. So now if I want to get a random number of records, so I will say where rand, like this. So that rand is random, and then limit, let's just get 2 random records, right? So selector from users where rand, like that, go, and you say we get, I say limit 2, but I don't know why I got 1. I guess it can give me what it wants anyway. And if I try this again, you see now I get different results, same query. If I go back, edit inline and go, look at that, different results, same query. So you can use this to get random values. Okay, so hopefully that has given you an idea of how these things work. What else have I forgotten? I should have written these things down, but it seems I didn't. So in the where clause, you can give it, actually there's one more that I want to show you. So let's say name, we can say where name is equal to, and then we say Mary, for example. Okay, let's remove the limit for now. So if I hit go like this, it'll show me the one that has Mary. But let's say I want to find Mary, I want to find also Joseph, and I want to find John. So let's edit inline. One way I can do this is to say where name is equal to Mary, and say or name is equal to John, and keep saying or, and so on, and keep going. So we can do John or name is equal to Joseph, like that. Okay, so if I hit go now, I will get all those results. You see, there's John, Mary, Joseph. Very nice. Now it's interesting to see the order here of these guys. So we're going to talk about the order as well very soon. But there's a more efficient way to write this query. Instead of this, you can say in. Instead of equal sign, you can use in. So you can say where name in, and then you put Mary, and then you put a comma here, you put John, and then you put another comma, you put Joseph. I don't know if this will work the way it is here. I think it will give an error. Let me just try it. Yeah, I thought so. So I just wanted you to see how the error looks like. So this is an error here. So to get rid of it, just click on it like that, and then we can go back and edit this inline again. Okay, so it's complaining. Of course, I know it would have complained, but the only thing is we have to put these in brackets like so. So you say where name in, and then you create this kind of thing, this kind of string where the values are separated by a comma, and these can be numbers. For example, if they're numbers, you don't need the quotes here. You can just say where Mary in name in 2, and so on and so on. But here we put these quotes because this is text. It may have spaces in it. So if you put the brackets like this, you can say where name in, and then if I try to open to run that, you see that I get what I wanted. Now you note the order is that it starts from the beginning and finds its way down. However, you may want to retrieve, you may want to do the opposite, like order by a different value. So I want it to order by the ID, which is the descending order instead of ascending. So ascending is from lowest to highest, descending from highest to lowest. So I can edit this and right at the end and say order by ID. That's the column I want to order by, descending. Now, if you want to order the normal way, you can say ascending, like so. Now, this ordering can get very complicated, right? You can say order by ID, name, and then you say ascending, right? ID, comma. But let's not get into that for now, just to give you an idea that you can do that, order by 2 columns. So here I'll say order by ID, descending. So here we are starting with 1, 2, 3, but if I hit go now, you see that the result starts with 4, 2, 1, right? This can be useful, for example, if you want to get the last 2 records that were entered, because if you try to retrieve two records starting from the beginning, then you to retrieve the first 2, and then you can change the order by to get the last 2. So without using a where clause, for example, you can retrieve the very last record by just saying select all from users, and then you just say order by ID descending, and the limit always comes at the end. So you say limit 1, like so. Now keep note that the spaces here do not matter at all. Okay, so don't be careful about that. Select all from users, order by ID descending, limit 1. So limit is always at the end, but there's one more that comes at the end, which is the offset, which we're going to talk about very soon. But just know that your limit should be there, comes after order. So let's go here, and we should get 1 record, which is the very last record. So you see, I got the very last record without specifying a where clause, just by telling it to order descending order and limit to 1 result. If I order this in the ascending order, I will get the very first record, like that. Okay, very good. So now that we are there, at least we've learned a couple of things here. Randomizing, hopefully it won't be too much. Now let's look at pagination. Now in pagination, this is where we have to use the offset. So let me do this for a second. Let me actually just read everything from here. So we've read all the records here, and now I just want to get page 1. So there are 2 pages here, page 1, page 2. If that is, we're retrieving 2 records at a time. So depending on the page, you have a limit. Let's say the limit on the page is 10 records, or sometimes it could be 20. So you want a way to find how to move between pages. So it's very simple, actually. I can say select all from users, then I can add my where clause in the middle here, whatever I want to filter the results by, but then at the end I can tell it how much to limit as usual. So in our case, I want it to limit to 2 results. So 2 is our page limit. So here I will get record 1 and 2, obviously. But then how do I move to the next record, to the next set? So that's 1, 2, which is page 1. Now I want to go to 3, 4, which is page 2. So in our case, we're going to use an offset. Now the offset tells it where to start from. So it will retrieve information based on whatever criteria you've chosen, including the where clause. So it's going to get that data and count how many of those items match that criteria. And then it will look at the offset and say, okay, I have to find at least 2 of these, then I start retrieving the results. So that's what the offset does. So in this case, we tell it to offset by a certain amount, which is 2, like that. So it will miss the first 2 and get 2 results after that. So I'm saying here, get everything from users. However, start counting only after you've retrieved 2 items, but then only retrieve 2 more items and then stop. So if I go, you see now I get 3 and 4. So like I said, you can put your where clauses here and all the filters here before this. So now the question is, when you're dealing with pages, how do you calculate the offset? Offset can be confusing. So for example, let's say here I want to limit to 1. So 1 item is 1 page. So if I do here, I want to get the very first item, I'll say offset 0, like this. So no offset whatsoever. If I hit go, I should get item number 1. Now to get item number 2, I'll tell it to offset by 1, just like that. Go, and there we go. To get item number 3, offset by 2. Okay, you see that? So I'm moving through pages just by changing the offset. Okay, now if, for example, I have 2 items per page and I say offset by 1 and go, so you see that number 2 repeats itself. So on page 1, for example, there should be 1 and 2. There we go, 1 and 2. On page 2, if I say offset 1 and say go, it will work, but number 2 will be repeated. So you can do things like this. If you want a previous article, the last article to be the first one on the next page, you can do something like that. However, it's always a good idea to have the offset a multiple of the limit, because here, instead of offset 1, I can put 2 and go. So if I add another page, I would put an offset of 4, for example. So let's look at a table that has more information for us to do this. All right, so in here, I'm going to go to the employees table. Now this one has quite a number of records, but we'll stick to the first few. So you see here, there's this numbering, employee number 1, 2, 3, 4, 5. So let's imagine each page has, let's say, just for simplicity, 2 items. So I'll go to there and say select from employees where, and say limit to offset 0. So that's page 1. So if I go here, you see 1 and 2. But now if I want to properly move through pages, I have to put 2 here as the offset so that it omits the first 2 items, because there are 2 items here. And then go, I'll get 3 and 4. And then the next time I have to omit 6. Oh wait, 2, 4, like that. I have to omit 4 like that, and then 5, 6. So you see that the number here has to match somehow the limit, because otherwise I'll be repeating the data. So there's a simple formula that I use, which is the limit, right? So let's say we have a limit. Now this limit is the number of items on a page. So if I have a limit of 2, and then the page number is equal to 1, like so, how do I find the offset, right? So there's a simple formula, and the formula is that offset is equal to, the offset is equal to page number. So let's see, page underscore number minus 1 times the limit. That's the relationship that is here. So let's see how this formula will work. So in here, we are on page, what page number is this? I'm not even sure now. 0, 2, 4. So that's page 3. So if let's say we're on page number 3, what will happen now is that this is 3 minus 1, which is 2, and then 2 times 2, which is the limit. Then the answer is 4. So you see that now the offset is 4, and so it's true that we are on page 3. If I want to find page 10, for example, I would do 10 minus 1, which is 9, and then 9 times 2, which is 18. So I'm going to offset by 18. So here I'll edit this and put 18 there, and this will be page 10. There we go. Okay, so hopefully that wasn't too confusing. At least now you know how to do random, what else? Random, how to offset, pagination, etc, etc. Okay, so now that we've learned all this, it's time to try this stuff in PHP and see how to connect to a database and how to run any of these queries. So in there, we'll just run a couple of queries because I've already shown you how the queries themselves work. Okay, so let's go to our PHP situation here. So I'm going to go to my htdocs folder. That's drive C, XAMPP, htdocs. This is where XAMPP and Apache server will look for our website. So click there and create a new folder. Call it CRUD, CRUD, for lack of a better word. And then in here, we're going to create a file. Now, I just want to drag and drop my folder into Sublime Text here. And let me just create a file in there. I'll call it new file. Save that file in the same folder. I'll call this file index.php and save it. Okay, so it is saving. Good. Now in here, I just want to put my PHP tags because we are using PHP now. And I don't need to close this because we're just going to echo the result. And we won't use any HTML at the bottom there. So to connect to a database is very, very simple. So what you have to do is just say con like this. Now this is just a variable, so you can name it anything you want. I'm just naming it con, short for connection. And you're going to say con is equal to, you say MySQL I connect, like that. Okay, so that will connect to you to the MySQL database. Now you have to give it a few items. The first thing is the host name, which is localhost every time you are on your local server. So it's localhost like that. So when you want to connect to one that is on your internet hosting account, they will give you the details that you need for that. So here, localhost, and then the second thing is the username and then the password. So our default user is root. Now, if you changed your username for your MySQL, you have to put it there. The default password is an empty string. If you're using mump, it's going to be root. And then finally, we tell it the DB, the database that we want to connect to. So we'll call it CRUD underscore DB because that is the name of our database. So this is exactly how we connect. Now we're going to put this inside an if statement so that if it fails, we get an error message. So we'll say if like that, so that, and then we put an exclamation point to say if it doesn't work out, then don't go any further, just die, and then die with a message and say could not connect. So you can put any message you want in there. So I will save this, and then let's go to our browser now, open a new tab. I'm going to navigate to localhost and then go to what we've created, which is CRUD, and then /index.php. Okay, so that's a page. So the fact that we do not see any errors, it means we are successful in connecting to our database. All right, so now that we are able to connect, we can start running queries. And to run a query is we have to create a query here. So we're going to name our variable query like so and say equal to like that. Okay, so whatever we put in those quotes is going to be one of those queries that we wrote in there. So we can put any of them in there, and then to run them, we have to look for a result like this. Now, these are just variables, so you can name them anything you want. Here, I'm just going to say MySQL query like this. That's how you run a query, but you have to use a very particular connection, and you're going to say con because that's our connection, and then you add your query there like so. The reason you must add a connection is because you can have multiple connections here. You can connect to different databases and put those connections in different names. So here you would have to use a particular connection that you want like this. And then if the result is good, you're going to ask the question if result like that, which means the result went well. Then I can retrieve information from there and say row is equal to. So usually you are doing you are reading from the database. Now, if you're just writing to the database, which means, for example, you are creating a table, all of these here, creating a table, creating a database, up to insert here, you are not getting any result from the database. You're actually adding information to the database, except for this, even the update actually, and the delete. So the only query that requires this part here is the select query when you are reading from the database. Otherwise, the other queries you should only use these two, and that's it. It will run the query just like that. That's more than enough. But when there's a result, you may want to read that result. So here you say MySQL fetch. Now I want to fetch a very specific ASOC like that. Sorry, like that. So this is an associative array. So you only do this if there's just one result. So here I will put result like so. And then once I'm done with that, I want to print the result to the screen. So I'll say print readable because it's an array, and say row. Why am I typing like that? Okay. And because I want the row to look nice, I will echo out some pre-tags here because it's an array. So pre-tags like so, just so the array could look cool. Now let's add the query here. We're going to just say select all from users. So this will read everything from the database. So let's see that in action. So if I now refresh the page, you see that there it is. It has read from the database, but we only see one result. Okay, so now if we want to see all of them, we have to go through a loop, because this one just fetches the very first item. If I repeat and say fetch again and show again, like this, for example, if I duplicate this, so the first item will be fetched, the second one and shown just like that. So let's see that in action. And you see, so this is ID1, ID2, etc. Now, because we don't know how many results will be returned, it's better to use a loop. So we're just going to say while, like this. So I'll say while this is true, while there's a result, then let's echo the result. Okay, we'll put that here, save. So it will try to read for as long as the result is there, it will return true, and then it will run through that. This will make sure that we return all the results that came in. So there we go. 1, 2, 3, 4. Okay, very good. Now, like I had said, if you want to use a different, if I try something like select all from employees, because this is a different table, right, from a different database, and I say limit 2, but let me take it back to users first so that we can see that limit actually works as predicted. So here we have all these results. If I refresh, now we have ID 1 and 2, and as usual, if I tell it to order by, if I say order by ID descending, okay, you can order by any column. The ID is just convenient, the ID column. So you see now I have 4 and 3. So everything works as predicted in the query here. Now, like I had said, if we want to use a different table, we can do that by just running a use query here. So I'll duplicate this query like that. I want to use a different database called employees. So instead I will say use employees like that. Okay, so I'll use a different database than the one that I put here, just to show you that this works here. So I will run that query, and then because I'm not expecting a result, there's no need for this. This is enough. And then I'll select all from employees like that, order by descending, and then limit maybe to 8 results, something like this. Save this, and let's come back here. I will refresh. Oops, I didn't get any results here. I guess order by ID. Oh, because there's no ID actually. So there's employee number underscore no, like that. So that column, the one I was trying to order by, does not exist. Okay, so I will see you in another one.